Hello everyone, welcome to AI Anytime channel. In this video, we are going to experiment with a new embedding model, Jina Embedding version 2. So it's a new embedding model in the town that has been, created by Jina AI. It's not a new name when it comes to AI community. Jina AI is a Berlin-based or a German-based organization, I will say, and they have been active in the AI community or in the AI machine learning ecosystem, mainly on the natural language part, and they later came up with Jina Cloud as well. Personally, I have used Jina in few of my projects earlier, even in the production level projects earlier, a few years back when they had different models and integration or some kind of orchestration frameworks when it come to deploying applications or the microservices, and they have a lot of templates. So now they have come up with version 2 of embeddings model. They have V1 as well, and the good thing about version 2 is that it supports more than 8K plus, sequence, like the sequence length is around 8,192 to be precise. So it 8K plus sequence length, which tends to outperform ADA 002, which is by OpenAI. ADA 002 embeddings tends to perform on some benchmarked on MTEB leaderboards, which is for embeddings model, the benchmark leaderboard. It has outperformed other embeddings model on few benchmarks, and so let's talk about it, and you can find it out the Hugging Face thing over here, the repository as usual. Jina AI, the embedding, some information. Not much of information is available about right now because they haven't released the paper while creating this video, so I don't know a lot about this, but we're going to experiment this, how we can try it out in Colab notebook or something, and then we'll see now how it's working. It has going to be three different variants. You can find out over here in the version 1 they had, which was based on T5, and if we talk about from an architectural standpoint, and the version 2, which is based on something based on a BERT architecture and based on JinaBert, which provides more than 8K sequence. The smallest one having 33 million parameters, and the thing that we're going to try today is 137, comparatively small when you compare this with other embeddings models like BGE embeddings by Beijing AI Academy, or sentence transformers embeddings model like MPNet or MiniLM, or multilingual E5, or any other embeddings. Now comparatively really small, and we'll see how it performs or something like that. Okay. Now an inference code has been given. We, of course, we're gonna depend on this inference code, and then we'll talk about it. So here is the Hugging Face repository. The link will be given in the description. You can try it out yourself. Now let's come back over here and let's go inside this folder called Jina V2. I'm gonna copy this over here, and let's copy. I'm going to open my Anaconda prompt. Yes, Anaconda prompt. Nobody knew that IntelliZ, the creator of Anaconda, is so advanced in future. Now we're talking about prompt engineering, right? So now let's go CD into it. And I'm going to just open my Jupyter notebook over here. So let's do that. Jupyter notebook, and it will open a notebook in the web browser. For me, it opens in Microsoft Edge. And you can see here I got my uh, viewer and all here, the notebook. So let me just name it here, guys, quickly. I'm going to call it Jina V2 experimentation. Okay. While creating this video, I don't see that there is an integration with LangChain, but in the next few hours or a couple of days, you will see an integration with LangChain for sure. Now, how do we import this, guys? So we have to import this from auto model class of transformers. So from transformers, there are two dependencies. If you want to install few things, you have to install PyTorch, Torch, and then you have to install transformers. These are the only two dependencies that you need. And you need NumPy, by the way. So you also need NumPy. So from transformers, I'm going to import auto model, and then I also need NumPy, the linear algebra module of NumPy, because we're gonna, do some cosine similarity thing over there. So we need that. So from NumPy dot lin algebra import normalization. So import norm, and you can see I am importing. I imported successfully. Now let me just do one thing. Let me create a markdown over here and let's first go in a little bit of mathematics here because that's what it has given on their documentation or the code snippet that they have given on the Hugging Face thingy here. Now what I'm going to do, create a variable, same variable that they have given, cost same, and they have used lambda to execute this in a single line of code. So lambda, a Python keyword, and then a comma b, which basically these are your two vectors. Now imagine if you have these two vectors a and b, and then that's how you go comma, and then you define your calculations or the computations. By the way, so here I'm gonna just do a dot product between the both the vectors a and b. We'll go in a bit of mathematics very soon. Now, so how do we write it? So a and at the rate, where that button goes. Okay. Now this is for basically your dot, and then I do a transpose if it's more than n two dimensional or n dimensional where n is greater than one. I will explain that. Now b transpose. This is how the formula you define, and then divided by the uh, normalization of both a multiplied b. Okay, so let's do that. Whew. Norm, and then go to your b's thingy over here. B. Now let's understand this. And if I just do a cosim, right, you just print a lambda thingy function here. Now let me just bring up my this. Let me just show how we can do that. Okay, let me bring my tablet here, guys. Okay, I want to explain that a bit. So, whew, let me open my toolcast here. Okay, and I'll just make my mic side here. It's okay, not required for now. Let me just okay, and here. Okay, let's write it down. I don't know why it's not. Okay, now it did. Cool. So here the let's write it down. So if you look at the formula here, right, what's the formula that we have written? So the formula is cos of cos same of the formula that we have written is of lambda, and there are two vectors a and b, and this is how you write. Then you go with your calculations, and it is a dot product b in transpose. Basically, it's used for matrix multiplication that at the rate that you see, right? And now then divides by your normalization thingy. So norm of A and then multiplied with norm of B. That's how you define the formula. Now, what do you mean by this, guys? If you're not familiar with this, let me make it simple for you. So here we have two vectors. A and B is your vectors. I hope you can see it at least. And let's break it down step by step. I can see it here as well. Now, the first thing that you see here in the formula is your A and B dot T. I hope you get the taxonomy right. That's what I'm explaining here. Now, this that you see is used for matrix multiplication. So if you have in your high school, we have all, or even in our engineering or wherever you were learning in your graduations, right? You would have studied about matrix multiplication. And then this B that you see is mainly your transpose. That's how you define it. Now, this entire thing that you see here that denotes the dot product between two vectors. So let me just write it, denote the dot products between A and B. That's what it denotes. Now, so that B dot T that you see here, that let me just cover it also. B dot E. If it's for one dimension, okay, if you only talk about 1D, so for example, for this you can say for one dimension, you can only write B. It is okay. You don't have to write. You don't have to do a transpose of that because it doesn't matter. It's both are same. B and B dot T is same in this context. By the way, in this context that we are talking is same. Now, if for 2D, or let's write like this, for ND where n equals to, or not n, when not equals, when is n is greater than 1, then it's different, then it matters, then it's more relevant. Okay, that to talk about. Okay, now here, if you talk about cosine similarity, right, let me just write it bigger and also simple calculation for you. Let me see if I can see it. Now cosine similarity formula goes like this. If you look at over here, it's a dot b, and it's this. So this become your dot product. This becomes your dot product, and then you have magnitude, okay, of both the vectors. So this is how you write magnitude of both the vectors, right? So let me just write magnitude, and you would have studied in this in physics as well, the scalar, the vectors, and then we tensors. Okay, so it's scalar, vector, and tensor. Okay, it's really intuitive. It's all mathematics that we're gonna talking here, right? We've been talking mathematics, and let's take an example here, guys. Now suppose if you have A equals 1 2 3 and you have b equals 2 3 4, how would you calculate? I have also shown this in my other video, build or create a vector store from scratch. I have shown this mathematical intuitions behind the vector stores or the cosine similarities, etc., in that video in details as well. Maybe you can check it out. I'll give the link in description. Now here you have two vectors a and b, where you can see the elements 1 2 3 2 3 4. Now how do we calculate? So let's first calculate the dot product over here. So in this dot product, how will you do, guys? A, and this is how you would do, right? B and T. So let's first do that. Okay, so here 1 plus 2 cross 3 and then plus 3 cross 4. How much is this total? So this becomes 2, this becomes 6, this becomes 12. So it becomes 20. Now this is your first thing that gives you the dot product. The next thing is the norm of A. So let's get norm of A. So norm of A, how will you define? Like this, and how much is this? How do you calculate it? What is A value? 1 2 3. So this is how you have to do. You have to do it in a root here. So 1 plus 2 plus 3, and then this becomes 1 4 9, and this becomes 14. We'll calculate that. I have my phone handy where I will calculate. Then normalization of B, and this becomes B. And how much is this? Let's count it out. What do we have here? We have 2 3 4. So this becomes 2 square plus 3 square plus 4 square. This becomes 4 plus 9 plus 16, and this becomes 29. Now let's just fit it in the formula. Now we are just calculating cosine similarity here. So cosine similarity, this becomes 20, as we got 20, and then this becomes 14 cross 29. Let me just use my phone. Okay, this came as 0.997. Okay, now if like it's closer to like 1, right? And this is how you calculate. So I'll give this in description. Now what we have done here, if you look at this formula that they have given on their Hugging Face, lambda of a b, which is two vectors a, and then you have this matrix multiplication b dot transpose, like transpose of b, and then you have normalization of a and b that you multiplied and get the cosine similarity. So for these two vectors we got around your 0.997, which is very closer to 1. Now this is what I wanted to show you from the formula standpoint. I hope you got a very high level view about that. Now let's jump in and see that how we can export and all, do the modeling and all here. Okay, so let's come back here in the Colab notebook, not Colab, by the way. I'm doing it locally. Now let's load the model here. So for model equals auto model, again we're gonna use from pre-trained. What will we do if there is no from pre-trained? Now we are relying on pre-trained models like anything, guys. Okay, from pre-trained, and here let's use the Jina thing. Okay, so there's an Hindi song as well on Jina or something. Okay, maybe it's okay, Jina, and then this is how you get the model repository, and you have to do trust remote code equals to true, because you're gonna use encode here, the encode function, and for that you need to have keep it as true. So trust remote, I don't know why it's not showing me when you need it, the auto intelligence or completions, whatever. Let's make it true. It will take a bit of time. If you're running it for the first time, it will take more time because it has to download the model weights, etc., keep tokenizer, the configs, etc., the model weights, and keep it in a your cache or anywhere you are doing it, and then it will take more time. And let it happen, right? Then meanwhile, I'll just unplug the charge of my monitor. Okay, now let's print the model thingy here. So once I print the model, you can find it out. It's a JinaBert model, which has your you can see the padding, the word embeddings has been used, the token type embeddings, the normalized layer, the dropouts, encoder, everything you can find it out in this verbose description of this model that you have printed. Now let's have an embeddings variable here, and in this embeddings I'm just going to do model.encode. So we're going to use encode function, model.encode, and it takes a list of like sentences that you can have. So let's ask how is the weather today or something like this. Okay, how is the weather today? And the other goes like this within the same list. What is the current weather? Let's ask what is the uh, current weather like today? Okay, something like anything. Okay. Now here let's just print the embeddings thing here. You can find out a list of array here, right? This is in the array, that numerical representation of your vectors. Now let's use this Cosine, guys. Okay, the Cosine that we have, the formula, very basic formula. Let's use Cosine. You can use different formulas as well if you want embeddings, but we are here using the same recommendation that they have given. Embeddings first one and the embedding second one. Okay, let's give it like that, and you can find out the score over here, which is 93. you know this is what cosine similarity is, guys. It doesn't look at the contextual meaning of your two different sentences. It's still more semantic, not that advanced as well. It looks still at your sentence similarities, okay, or the word similarities, or if you come on the tokens level as well. Now let's create a function quickly, guys. To define compute similarity, just to quickly try it out, 4 5 different thing here. Now compute similarity, and I'm going to give sentence 1 and I'm going to give sentence 2 because these will be my input as a parameters, and then just use the embeddings thing here. So embeddings equals, we already have model.encode, so let's use that code from there, model.encode, and then just pass inside a list, which is sentence 1 and sentence 2. That's it. Okay, and then you have your result thing over here. So result, then use the cosim thing here and the cosim, and then it's a function, pass the embeddings first and the embedding second. You can have n number of thing here. Okay, that's how you write a function. And let's just do a return result here. Okay, now let's use this similarity here, something like this, similarity, compute similarity, and compute similarity. And here I'm just gonna pass, let me show you something. I love apple, and then I like banana. Just look at the result here, guys. Oh, I have to print similarity. And look at the result here, like 78. Okay, I love apple, I like banana. I mean, that's the, we will talk about it. So I'm creating a playlist of evaluating LLMs and RAGs approaches, and where I'll talk these things in detail. That you should not always look at cosine similarity. It depends on what you want to do. But here it is okay. So let's look at something else as well quickly after changing it. So I love apple. Maybe I'll just copy this, and here I'll just write I like, for example, let's write I like OpenAI, and I will just here write I don't like OpenAI. So I'm being neutral here, guys. Okay, I don't like OpenAI, and then similarity again. Look at the score, 89 or something, right? So you can find it out here what I'm trying to say. So if you look at the contextual meaning, then you have to look at the matrices in some different ways. Okay, and here let's try something last quickly. Uh, let's write let's write the same thing. India is going to win the ODI World Cup 2023, and then India India might be the winner of the ODI World Cup, and then just do similarity, and you can find it out over here, right? So this is how, by the way, it works. It's not much detailed information about Gina, but You should uh, expect a few more videos on Jina very soon, because I'm waiting for some integrations and how we can use it in our RAG approaches, etc., and then evaluate the performances. This video was a quick one to show you a quick 20 minutes video that how you can, inference it, understand cosine similarities, etc., how it works, and that might help you to be updated with different things happening in the generative AI ecosystem. So the code will be available on the GitHub repository. The link will be given in the description. Let me know if you have any thoughts, feedbacks, questions. You can comment it down. You can also reach out to me through my social media channels. The links are available on YouTube banner and also on the channel about us. Uh, if you haven't subscribed the channel yet, guys, please do subscribe. And if you like this video, please hit the like icon and share the video and channel with your friends and to peer. Thank you so much for watching. See you in the next one.